Hi, this is Mrs. Davis. This is AP Pre-Calculus. This is review for Test 2A, and we're on free response question number 7, actually. That didn't get changed. So this is, again, right out of College Board, so let's make sure we understand this. We have a bacteria being grown in a Petri dish, and it's modeled by C of T is AB to the T in square centimeters at T hours. So A says use the data to write two equations, so it's very similar to the one we just did. So we would say A, ready? 0.4 equals A times B to the 0, and 0.6 equals A times B to the 1, right? So that's what they gave us. We're using these two. Okay, and then it says that was for I, and for I under A, it says find the values for A and B. So A equals 0.4 because this is 1, and then to find B, we'd say 0.6 equals 0.4 to the 1. And so B would be, B to the 1. So B is 0.6 over 0.4, which is 3/2. So now it says, let's just write what this is. This would be C of T is equal to 2/5, which is 0.4, I'd rather use fractions, times 3/2 to the T. Okay, probably need that later, but. So B says use the given data to find the average rate of change. So again, does it say use the data that can be defined an expression for C of T? So we have that. Find the values for A and B. Use the given data to find the average rate of change in square centimeters from 0 to 2. Express your answer as a fraction and show the computations. So we would say the average rate of change equals f of 2 minus f of 0 over 2 minus 0. So 0.9 minus 0.4 over 2 is 5/10 over 2, which is 1/4 centimeters squared per hour. So then to say what that means, get down there. To say that means, interpret the meaning, we would say on average, as time increases from 0 to 2 hours, the area increases by a rate of 1/4 centimeters squared per hour. Okay, and then 3 says use the average to estimate the area of the bacteria at T equals 3. So we're going to have to do M is 1/4, and we'll use the 0.02 to write an equation. So y minus 2/5 is 1/4 x. So then we can say y is 1/4 x plus 2/5. So at T equals 3, y would be 3/4 times, plus 2/5. So that's 23 over 20 centimeters squared. And then C says, does the model demonstrate exponential? Did we do the 3 hours? I always skip that. So then, yeah, we did at 3 hours. Okay. So then We go back to C, does it model exponential growth or decay? So the model, we found the model would demonstrate exponential growth, because what did we get for our rate? 3/2, right? So that's greater than 1. So the model found in part A is exponential growth, and say why. Remember, because B is greater than 1. Let B is equal to 3/2, which is greater than 1, and A equals 2/5, which is greater than 0. All right, so that was the last free response.